Just about time to begin. We'll wait a couple more minutes for folks to join. But as we wait, while we wait, we need a note taker. Who would like to be the note taker? And normally Jake is our note taker, but he is the star of the show and will be doing most of the talking today. So it's probably not good to have him. So who else would like to be the note taker today? Just a reminder, this flight cannot take off unless we have a note taker. And it's not that difficult. It's actually fun, which isn't true, but it is necessary. And don't worry about if your note-taking skills are weak. We do fix them in post-production. So, who would like?
It can be fun. You can like stick in little editorials, and because nobody ever reads them, then it's fine.
Put some Easter eggs in there. Some subliminal messages for posterity. All right, and of course, just a reminder, anybody, if I will begin the uncomfortable task of asking people soon, so. And looking down doesn't help in a remote meeting. So. Nils, are you interested in taking notes? It's a great way to stay awake on a Friday evening when you'd much rather be doing something else.
Do that. I take notes. Yeah. Well, yeah, I'll do it.
Is that Bill? Okay, that was Bill who said that. Okay, well, thank you, Bill. We appreciate that. And so we have that knocked out of the way. We'll wait one more minute for any last minute stragglers. The good news today is we have plenty of time, but I can assure you we will be done early. So that is the best promise I can give. Fortunately, time slots, we've discovered the hard way that 1 hour is not enough. 2 hours is kind of too much. So looking forward to someday having 90-minute slots again, because those would be the Goldilocks slots. Okay, I think we can get started. Welcome to MBONED in IETF111. I know you have many other choices of working groups to join, but we appreciate you joining this one. Here's the note well. Please note it well. It looks very similar, in fact, identical to all the others that you've seen this week, and we'll see the rest of today. Here's our agenda. The usual status of working group items. I'm going to give a very brief multicast deployment update and for some interesting projects going on. And while it looks like only, there are a few people on there, the truth is Jake has the lion's share of the working group documents. So he will think of this as 4 separate slots, if not more. So he's going to cover those, and he'll be able to dive into detail. Lots of exciting work going on there, and he can hopefully maybe talk about some of the work that's been kicked off at W3C. Anybody have anything else they would like to add to this agenda? Okay. So moving right along, in terms of active working group documents, the long-awaited multicast problems draft that had been sitting in AD review for a long time with many discusses was finally cleared. Mike and team were able to send out revisions to that a couple weeks ago. There was one more issue that was addressed, and that has been sent on to IESG and approved for publication. So I believe Warren is one of the authors on that. I don't know that any of the other authors are here, but congrats on finally getting through the gate on that one. I think that had been sitting about a year in AD review. So thank you, team, and thank you, Mike, for submitting that. The Yang models draft, Sandy mentioned that she is going to be updating that soon, and we'll be sending revving that. The multicast to the browser drafts that Jake is leading. He's going to provide updates on each of those. Actually, there's 3. I don't know if Mnat counts, but we're tangentially involving that one. And the telemetry draft, Mike said progress is being made, and he expects to update that soon as well. There is one other doc, the redundant Ingress failover draft. This was presented in IETF109, kind of looking just for feedback at the time. They did not request adoption at the time. According to Sandy, they think they're getting ready to, they think it's just about ready for adoption. She may be asking for adoption, or she may wait until IETF112 to present it and then ask for adoption. So keep an eye out on the mailing list for that. And that is it. Close this deck and share the next one. All right, so next up is a deployment update. So just as a reminder, one of our charter items for MBONED is to give periodic updates on what is going on in the world of multicast. So thought it's a good time to do that. Some interesting projects going on. They're very early stages. So just wanted to share with folks some of this work. A new project called Off-Net Sourcing is being kicked off, and it's being developed right now. They're about ready to post some prototype code, but it's still early, not ready for, we're pre-alpha, but hopefully in the next couple of weeks we'll have something that's prototypable and demoable, and that it essentially allows translates. It's a translation box that would sit at the border of the multicast enabled net part of the internet, the MBONE, and it would take in a unicast stream and spit out as a multicast stream. And I'll talk about that in a minute, a little bit of what that would look like. Also, in IETF110, in the beer working group, some folks working with Giant, which is the research and education network in Europe, presented about a P4 network that they have deployed. And they recently added beer to the routing stack and the P4 code, and they were able to, they demonstrated, or they described that deployment and the implementation. I encourage, if that sounds interesting, please check out the proceedings. Click on these 2 links. You can see the slides as well as the video for details on how that worked. Subsequent to that, after seeing that, we reached out to them to say, hey, if you've got beer running, wouldn't you like to extend your reach to off-net receivers with AMT? So there's an investigation afoot. We're at the early stages of that as well, to add AMT relays to that deployment, so that the content that's currently being delivered by beer in the underlay can be delivered to receivers that are off net. So going back to the first project. So right now today, I've presented a few times in this working group about what we've called at times multicast to the grandma. Basically, it's an architecture that delivers multicast for everybody on the internet, not just the privileged few who seem to be connected to the MBONE. The first step that we've always had working is on-net multicast, which is you have native sources, native receivers, and that just works the way multicast has always worked. That's been around for 20-something years. And it works today. The MBONE is comprised mostly of research and education networks like Giant and Internet 2. So that's been working forever. More recently, the last few years, we've added off-net receiving, which is you can deliver native multicast sources to unicast-only receivers through AMT. There are currently 4 AMT relays deployed across the internet, across the MBONE. All 4 happen to be at Internet 2 member institutions today. And you can see this and enjoy this on the multicast menu. I can send the link to that, but I've presented on that in the past. So what's new? What's being worked on right now, the effort underway is to add off-net sourcing, which is, imagine you have let's say a cell phone with video, and you want to send a video stream via unicast to a translator that would take in the unicast stream, spit it out as multicast, and then it can be delivered to on-net receivers natively or off-net receivers via AMT. Like I said, we're at the early stages of that. What do we need most right now is interesting content. All network innovation is driven by compelling content. We'd love to believe that it goes the other way around, but the truth is content drives the network. Cool content comes out that people love, and the folks in networking build architectures to support that content and those applications. Hopefully we'll have some working code to demo by IETF112. And if anyone has specifically interesting content that they would like to share, please reach out to me, or if you'd like to be involved in either of these 2 projects, please let me know. Questions? Jake, you're up. Let me see here. Oops. There you go.
Yeah. So there's also I was in. I think there was some ongoing work, but we've also discussed on this topic with Giant and a bit with I2, the notion of adding the off-net ingest for generic multicast as well. This is the way that we're aiming to deliver traffic, the content that we hope to bring up, and so it would be a good that is still tentative. We haven't begun work on any of that, but yeah, we're aiming to deploy the prototype ingest platform and start sending a bit of stuff in there. Just wanted to add that in.
Yes, and Jake, were you going to talk a little bit more about that in your next presentation? The off-net.
Yeah, I wasn't actually. I thought you were going to mention that, but it's the same. It's that same architecture.
Okay.
I could
the Dryad architecture stuff.
Yeah,
I didn't want to steal your thunder. I thought.
Right. There's one more slide I started adding, which is not just a single path back to a route, but a path to many external non-multicast links. I have not put that slide into the current deck. It's possible to pull it up if anybody wants to see that one, but that's the take I've been using on the I2 and Giant discussions. So yeah.
Cool.
But it is the same architecture. You just have to think of a few different ingest points with potentially virtual links back to them from edge bottlenecks of the path of some sort. It's really just for the RPF, so that instead of propagating your join to some location that does not have a multicast capable next hop for the RPF, it propagates the join over a link to an ingest point, and then from there pulls in unicast. So it's certainly the same concept.
Cool.
Right.
Any other questions about these two projects or deployments, or any interest in, like I said, if anybody's interested, shoot me an email. But any other questions about it? Okay, with that, I will turn things over to Jake.
All right, thank you.
All right, now, Jake, you have the stage, and
great.
You have as long as you want. You have an hour and 43 minutes, but please don't take all of that time.
I think I asked for 30 minutes, if I remember it. I'm surprised to see that I have 60. Okay. Great. So I'll be talking about the status on these drafts that are working group items, and also the status of our ongoing effort to sort of turn this into a generalized multicast, democratization of multicast. I've heard a few people call it. So as compared to last time, I put a few slides in here just to give a reminder, sort of overview of what this architecture is, because I felt in the last couple of meetings like I've skimmed it, and I believe there are some new people who might be seeing some of this for the first time, or weren't there in the earlier presentations about these things. So it'll be brief and hand wavy, but it's the overview that can accompany how these things work. I'll give an update on the status of our outreach efforts and the ongoing development work on this, and then the next steps and document status. So first off, to give a reminder overview of how Mnat works, what you have is a situation where, for whatever reason, you've got an internal part of the network that cannot handle general external addresses. We encountered a few of these in the trials we were running. I put some of the motivations list in the Mnat draft, and this was more common than we had originally expected. It can address 4 to 6 kind of addressing challenges, as well as work around the wide variety of problems we see in some of the vendor implementations for various multicast, like sort of multicast capable on-path devices. But the idea is that from the client app, it's the same. You express an intent to join an SG, and something on the path. And this, in the original slides, you can see that this can be embedded in the app itself, or it can be an upstream device, such as a home gateway. But it will be in communication with an Mnat service that runs the Mnat server, and this will provide a mapping from the external global SG into an internal, within this network, locally assigned SG. And then this local assignment is what gets propagated through the actual multicast portion of the network, and then at an ingress point, it would translate back, also by talking to the Mnat service. It will translate back into the global SG to subscribe externally. And what this allows is this will interoperate and now allow the client device to For example, with the authentication through AMBI, it's tied to the global addressing scheme. So it's important that the client understands that it's trying to join this global address. But because of various kinds of workarounds on the transport side, including either V4 in V6 networks or V6 in V4 networks, as well as the some of the kinds of hardware things. I think I have a slide that mentions some of the things we encountered. The on-net portion of this can be managed by the local network in whatever way works for the gear that they've got, and for the configuration they've got. So so this, we have a prototype running, and it's got a few bugs, but it seems to be doing okay, more or less, and we're working it out and figuring out how we're going to get like a suite of products that would support this, that are available for the ISPs to consume. So yeah, that's what that draft is about. There's 3 drafts that go together, which are DORMS, AMBI, and CBAC. DORMS is the sort of substrate for communicating metadata about SGs in general, that can be published by the sender of the SG. And then AMBI and CBAC are both extensions to DORMS, and they allow for consumers of various different kinds, including the receivers and on-path devices that need to process the traffic in some way, to go find out what that metadata is going to be. And it's just a sort of globally discoverable through DNS and then through a standardized web API, how you get that metadata. So the idea is that, source 1 and source 2, they each just publish a SRV record in the DNS. And this refers to a specific known DORM server. This could be the same DORM server for the 2 sources, but it doesn't have to be the same DORM server. So the source knows about the DORM server that has the information that it manages. And anybody who needs to discover this information finds out that DNS response, follows it to connect to the to this REST-conf server, which is using then the DORMS Yang model inside it. Inside that Yang model, it carries information about how much bandwidth that stream is going to consume. It also has the right URLs to go to get the authentication stream, so that you can authenticate the data as well. And so you can use this information about the bandwidth that the stream is going to carry to decide whether, as a network, you would like to ingest and forward this traffic, so that you don't go signing up for a 100 gigabit stream when you're, a 10 megabit sort of provider, so that you don't have any sort of bandwidth constraints. These DORM servers it's just using HTTP as kind of the way to, and Yang as the way to describe the structure of the data, and deliver it to anybody who's asking for it. So it's all read-only from the sort of generalized access, and in fact, typically going through a CDN, at least in my deployment. And then you're making decisions about what to do with that based on the rest of the draft that explains how you process that data. So that's the basic idea for how those things all work. And what AMBI is actually doing for the authentication is all the packets that are being sent over the network to be delivered through whatever your multicast forwarding technology is, are also getting hashes of those packets that are sent through a sort of live stream that's secured, that carries the authentic and cryptographic proof that a sender in control of this secured stream knows what packets were being sent, and that the contents have not been modified en route. So so if you get a packet that doesn't have the right hash on it that's on that channel, it means it either got modified or has been spoofed, and you should reject it and not try to process it in the application, and probably also in the network. And then if you get any hashes for which the packet never came through, then you can treat that as a loss and respond appropriately. And then so these are the basis of what we're using to try to build out the browser support. And the outreach that we're engaged in started with the ISPs, they being the key sort of components of making sure this will all do anything. We started trials with 5 ISPs where we set the whole thing up with the ingest platform and made it run with the gear in their labs. The different ISPs we engaged with had a mix of fiber cable DSL. We had them use a Wi-Fi router that was one of their Wi-Fi devices. We talked with them about the practicality of getting the Wi-Fi deployed. In some cases, they don't control all of the Wi-Fi routers in their customer base, but it's sort of increasingly common that they have a significant footprint that's amenable to at least setting requirements for them. And so in some cases there's a sort of maybe 6 month or year sort of delay in terms of making sure that the Wi-Fi router will do the IGMP snooping and propagation, etc. But the ones that looked into this found that in general they believe, sometimes after conversations with their vendors, but found in general they believe that they can drive updates of those to ensure there is support for the at the Wi-Fi layer, and we're able to get the devices that they use for their ordinary networks to do the multicast propagation. Again, sometimes this needed some discussions with their vendors, but in general they got this working. However, 3 of them needed to use Mnat. One of them was for IPv6. This actually was they ran it through their production network for that one. There was a sort of lab deployment of the ingest, but there was a production on-net receiver that they were using to do the receiving of the traffic. The others were all lab productions, but using their normal gear in some sense. The ones that some of the ones that used Mnat, 2 of the ones that used Mnat, and we called a successful outcome, were needed to use a sort of on the OS side, south of the Wi-Fi router, to do the egress, and so that tended to indicate to us that we might need to bake something into applications in order to do the Mnat egress side. Lenny, it looks like you've got a question. Should I stop here and take it?
Yes. Can you elaborate a little bit on the ones that needed NAT, Mnat? Just what those use
Yeah,
cases were about the V6 and the V4. When
sure.
you say V6, was it you had a V6 only receiver and it was V4 content, or vice versa?
So
And
this
what
was
about the other ones?
so we had V4 content running, and there was a V6 only network. Now we would have been willing to stand up V6 content, but we thought this was an interesting use case, and they had some other requirements too. One of the requirements was that the source of the traffic had to be from inside their network, so it had to use one of their assigned IPs. This was a business requirement from their side, so this was not going to be possible to integrate with the authentication scheme using the global IPs unless we arranged something in that way. We wanted to be able to use the same sort of globally authenticated delivery, and so we thought this would be a good. This was after we had already gotten Mnat working for 2 other cases, and so it was uh, uh, a sort of natural fit to keep trying it. I think there might be like other approaches that could do this differently. But what we did is with the external traffic, we it actually had to all come from, it had to use the same group for traffic from the same sources. So it was kind of a funny setup where what we had was like 8 or 10 different source IPs assigned to us, and they were all mapped through the Mnat server with the sort of per um, managed by that network, using addresses assigned by them to the same group address, and then the receiver would still join according to the globally available SGs that were learned by the application, and using the same traffic as other people, but it would be mapped inside the network into this sort of specialized requirement and that was around handling their RPF constraints. Um, some of the others had a
So just so I understand,
yeah,
so basically you had S global, G global, and the subscriber would subscribe to S global, G global, but that PIM and the data, the join as well as the data got translated along the way to S local, G global.
correct. No, S local, G local. They were both remapped. So
Oh,
you
okay.
could stick anything into the assignment pool,
Mhm.
um, you know, but in fact for this it was a local group assignment also. Um, so I can speak to another case we encountered as well. Um, there was actually I think I mentioned it here. There was a Nokia OLT, I believe that the way they did the traffic segregation was through the MAC address, so it was done at layer 2. So this was assigned into different VLANs, and the different VLANs, one of them was running their TV service on it, and they wanted to make sure that it wasn't that was kept separate from this sort of off-net multicast that they were going to forward through, right? So, but the way that those VLANs were assigned from the constraints in the vendor that they had came came from the layer 2 MAC address assignment. But the layer 2 MAC address assignment uses only, so this was IPv4, so it uses only the bottom 23 bits of the Ethernet MAC address, which comes from the bottom 23 bits of the IP address. And there's no way in general for the 232 space that we could be using anything to avoid colliding on that bottom 23 bits with their internally assigned groups that they were using for their TV service. So so this meant that the traffic, when it collided, would get assigned into the wrong VLAN and would get sent to like their their set-top box instead of being sent to the subscriber that was trying to receive it. And so Mnat was a an effective workaround for that, because they could ensure that the group spaces in the assignment pool just were divergent, and so they could always make sure that they were assigned to the right VLAN. There was one other case. There was somebody, we actually started to look down this path for Calyx. I'm not sure if it would have panned out, but we ended up just setting it aside and saying that it wasn't going to work for them. But the idea was that and we've actually encountered this in a couple other instances as well. There are some cases where what we have is an ISP who's operating a TV service, but they're not doing any dynamic multicast groups propagated through their network. So there's no joining that gets propagated. There's no operation of PIM. What they have instead is a sort of, in some cases, it's just sort of over a QAM layer. For instance, I'm not sure if I pronounced that right. It's QAM. That is used in cable, and what they've got is just a static assignment of multicast group address to a specific QAM, and then so they've got this sort of list of static group addresses that they use for their most popular TV stations, and sometimes what they'll say is, well, I guess as long as it's under the rate that we use normally, then it would be okay for us to take our few least popular TV stations and let you use the groups that are assigned to those, but we don't want to reconfigure the network. And so what we'll do is, and so for this case, Mnat actually can work just fine, where what you can do is give the pool of assignments can be configured to whatever those static groups are that they've set up to be assigned to the broadcast transport that they're sending the packets over, and then it'll get sent through without having to reconfigure all their all their whatever DSLAMs or CMTSs. And then it can get unpacked back to the global SG back on the back south of that access layer. So that's the intended operation. Did we do the static assignment? I think well, we did run it that way. I think it was because what we did in practice was they had some static groups that they configured in their lab setup to make sure that would be okay. But I think that one was a little bit like, well, we think this will map to the same thing. So it was perhaps a little bit less realistic. But their conclusion is that they're nonetheless interested in investing in this if the traffic's actually going to come and if other people invest in it also. Hopefully that answers your question. Let's see. Anyway, we are, huh?
The V6 case, so you had a V6, a V4 source, and you needed to get it to a V6 only receiver. So you essentially translated.
It was so it
V4.
was actually on the receiver. Yeah, they only had V6 connectivity, but inside it can. Yeah, I guess that's the case. What we actually did was we ran it at the OS layer. So we set up an internal interface that had V4 connectivity, and the joins were routed into that internal interface. And then that interface was running our instance of the Mnat egress. The egress was talking to the server, which was configured with the assignment pool, and was configured with the upstream being the actual. They just had the one upstream interface for the receive device, and so on that external interface for the actual receive device, it had been turned into a V6 join. And so the only thing that the network saw was the V6 join, except just right inside the Mnat server and the egress and ingress.
Cool. And it's been a while since I read the Mnat draft, but was V4 to V6 translation part of that? Was that specified in there, or vice versa?
Not specifically, but it's certainly permitted by the structure of the Yang model, right? It's like I was actually looking for a good way to ensure that with a I think that's in my latest version of the draft update, which I'm not sure it's posted yet, but I was looking for a way to ensure that if you've set the source address to a V4 address, that only V4 addresses appear in the group address and vice versa for V6, which I haven't seen. there's like ways to put constraints into the Yang model. So I was digging around on that a little bit. I think I did it through a regex that I'm not super confident about, but I'll be looking for, for some feedback on that at some point. I think it might have just been like, does it contain a colon? Which IP6 addresses do, and IP4 addresses not so much. But there might be a better one to use. Right. But yeah, I mean, the point being that that's mentioned as one of the use cases in the Mnat draft. It doesn't need any special defining exactly, because all you do is you map it into whatever the locally assigned address is. And so as long as you're allowed to specify a v6 address as your local address and a v4 address as your local address, it can be anything. So that's so it's not explicitly called out except as one of the use cases that's supported. But yeah, great. Oh, and we are actively continuing some talks with some after these trials have concluded. We're following up with some other ISPs that have also expressed interest and deciding whether it makes sense for them. We're basically trying to drum up as much interest as we can at this point and sort of see, do we really have the critical mass to roll this out and have confidence that we're going to be able to deliver, substantial traffic this way. Likewise, our content customers, with the prototypes that we put together, we believe that there will likely be some changes required for the content customers. For the video side, we think that it can be done in most cases by just using a different player, but sometimes they have restrictions on their players, and on wanting, like, sometimes there will be custom extensions to the player that they're using, or something along these lines. So we want to make sure that that it's going to be a player thing that can make sense. Also, the browser work hasn't really been pinned down yet. It might be that we can get it fully transparent and put into the browser, at least for segment transport, for the video support. But that's all sort of still in development, so I think it's still a bit of a moving target to get commitments on. But we're also talking with some of the customers that do large file delivery use cases like video games and OS updates, and looking into whether something that looks kind of like our prototype can be reasonably integrated with their downloaders. We do think that this would require some updates to the software of the downloaders, but they all have that kind of auto update capability in order to do this sort of thing. And so we're trying to nail down evaluations on whether that's going to be viable. So that they've been working with our prototype a bit and looking at its behavior, and whether we need to develop a different kind of protocol or use something else in there is still a sort of ongoing thing. But we're trying to nail down the expectation, both that we'll be able to deliver traffic if we have traffic, and that we will in fact be able to deliver the content customers we have will in fact be able to do this, because it takes all three, right? It takes the network and the customer and the CDN. Any of us can say we don't think this content should be multicasted right now, and then it would not be multicasted. But we think that particularly for these big events, there's enough value in making it multicast that as long as we all three do want to do it, that it's looking like maybe we can get this to happen. I'm calling this cautious optimism. I think none of this is really a done deal, but everyone we've talked to is still saying, yeah, this looks like it might work. I don't see anything wrong with it, and boy, would it be nice to not have these havoc wreaking sorts of traffic events several times a year, in some cases a few times in a month. So yeah, so the browser implementation in the early part of this year, we tried to to submit it into Chromium. We, I think during the last IETF, I said there were some process roadblocks, but it's not just process roadblocks. It's really like more like technical objections. And this initial submission was rejected for inclusion in Chromium as an experiment. We got some feedback on what would make it better. And so we're trying to follow up on that feedback. The sort of key takeaway here is that this would be a new kind of mixed content, and it would be not appropriate from the sort of Chromium network development team's point of view to include this as a sort of Chromium-led experiment. So we're trying to gather the consensus of the web community and the IETF community, and come up with sort of a well-documented set of security considerations that goes with this. We've written mostly Kyle, I should say, has written this draft for the multicast security considerations targeted toward delivering multicast for web traffic. Web traffic, of course, has a lot of security work that's been done and that has been necessary for the development of the web over the internet, and we are keen to not break any of that. So we're trying to make sure that we get all these pieces in place to get that to happen. To that end, we've created a W3C community group. I think I sent out a note about that to the list. Actually, I think somebody else sent it out first. I think it was probably Brett. Thank you, Brett. I'm trying to get all caught up on keeping everybody in the loop who should be in the loop. But that group started last month, I believe, and we are starting our regular monthly meetings, first Wednesday of every month, starting next week on the 4th of August. Please do go take a look at that if you are willing and able to join a W3C group, and we can discuss all the security considerations for the web in more detail and try to work on getting the web APIs into the state they need to be to make this work. I should say that the Ambi implementation, like we do have a bad Ambi prototype to just sort of proof of concept the performance characteristics of doing the hashes. That was done in Python, and a couple, maybe a year and a half ago now at the hackathon, at an IETF hackathon. But that's going to need a production quality implementation before any of this can go into the browser, and that's one of our big next steps. There also were some considerations raised about the one of the things that was set as a minimum for web traffic is encryption, which we don't have as part of Ambi. So we're looking for the right solution on how to approach that. And this is one of the key questions in the security considerations document, is about like when you have a encrypted session that's one-to-many, what are the sort of constraints on the kind of traffic that can be on that so that this can be a safe communication, and what is the threat model for which encryption provides some level of protection. We think there is perhaps some, which was one of the outcomes of the NetDev thread discussion. There's a link on this slide. But that is, and that's, it is a very fine point that for anyone not in possession of the decryption key, it is hidden from their view if it is encrypted. And so this does prevent some passive on-path sniffing attacks, and require them to become active in some sense to obtain a key, perhaps without authorization, or perhaps without authorization to use it in the way that they would need to use it for providing a threat model. I think that discussion is really just getting started, and there is some risk that the conclusion would be that there should be no IP multicast on the internet, according to a security perspective. And if that's the kind of IETF consensus that emerges, then well, we can close this group down, I suspect, but I don't think that's really what it should be, because it just moves the security problems elsewhere in the ecosystem. So I think there's a right way to articulate this balance, and we're trying to find it and do that so that we can, move forward and with sort of community consensus agree that this is a well-considered good idea for how to get web traffic in there. There was a side meeting yesterday that went pretty well, where we talked about some of these ideas, and I specifically asked if anybody thought that this is doomed and a bad idea. And among the people who chose to join that side meeting, nobody thought that, so that was good. But I think that there's still some a few miles to cross before we get before we really have IETF consensus that this is going to be possible to do in a secure way. But we're trying to get all those T's crossed and I's dotted as we move this forward. So we'll see how that discussion goes. We're trying to find the right IETF venue for that discussion. Certainly, I encourage people to join the W3C multicast group. That's a multicast community group, and discuss and raise concerns on there, and we'll see if we can get them addressed. To me, the problems that have been raised do look addressable, and under a proper consideration of the threat models, I think we can come to consensus. There's a good way to deliver a set of safe traffic, but we need to write down what all those things are before this can go into the web browser. So we were trying to do that. In the meantime, I'm carrying a fork of Chromium, and anybody who wants to try it can find it if you search for Chromium. I hope I have a link to here, but I can send it if I need to in a follow-up. But it's Chromium_fork under the Grumpy Old Troll GitHub repo. Oh, yeah, there it is. Yes. Right. This is mostly what I just said. Forgot I had another slide for this. So, there is one other point here. This one of the big options for doing that encryption is by using Quick, and I think we have a really good starting point there in the already currently active as an individual draft, the draft Pardue Quick HTTP Emcast. This describes a good way to standardize delivery of objects over multicast. It provides for sort of unicast recovery by doing range requests of known HTTP URLs for any missing packets that can be detected in the quick stream. There's an implementation of it, and so this is our sort of proposed next step to start looking at this, because it does provide for encrypted packets using the symmetric keys that are part of the quick stream. And then we're going to try to do some kind of an integration between that and Ambi, so that you still have the sort of hard protection for the authentication, and the kind of weaker protection for encryption that you get out of sharing the decryption keys. But there is no need under Ambi to share any sort of authentication keys, and so what you get is a really solid authentication protection if you use Ambi, and the sort of hopefully appropriate degree of multicast privacy protection through and confidentiality protection through that you can get through the use of shared encryption key, shared decryption keys, at least in a multicast stream. So so yeah, that's our kind of next project that we're going to be trying to dig into and make sure we can get this moved forward. I don't exactly know how long it will take. We haven't started this work yet, but we will be investigating that and trying to make sure that it can move us in the right direction, and actively seeking feedback from anyone who will give it to us. But if you want to try it, you can download a binary from here that will run on Debian-based Linuxes, I believe, and please do participate in the community group if you can. Yep, and the more shilling the community group, right? So in terms of our IETF docs, I did some. I got a Young Doctor review from Rashad. I addressed the feedback that he gave in the dorms and CBAC drafts. I think there's some similar stuff that's going to go into Ambi, and actually, I'll also be applying some of the concepts in Mnat. But in dorms and CBAC in the latest, I think that they're committed. I think dorms might be ready for last call. I don't think I have any other TBDs in there. So I guess I'd like to start the dorms last call. I was thinking about it, and I think it makes sense to do the dorms last call ahead of trying to do the CBAC and Ambi, because if there are any changes that end up needed in dorms, then it may impact what we have to do in Ambi and CBAC. So I'd like to sort of get dorms pinned down, and then have that ready to go. There were some substantial updates put into Ambi. There's a section about a threat model, and made the manifest scheme more extensible with the TLV space. It looks like Lenny has a question. Do you want to jump in with your question, Lenny? There you go.
Submitting them together. Can you hear me?
Sorry? Yeah, now I can hear you.
At one point, there was a discussion about clustering the documents and submitting them all together at once. Do you think they need that, or
I think
Ambi and
it's
CBAC should be clustered and dorms can go first? What's your thoughts on?
I think it would make sense to put them in a cluster. However, I don't think that a cluster means that they have to be submitted together, if I've understood it correctly. It just means that these are related in some way that provides value in keeping them linked at the RFC editor sort of level. Right now in dorms, I do have some forward references to Ambi and CBAC as examples of how it can be extended. And I think, so the way I see this playing out, if we do that, I'm a little agnostic on whether it needs to be a cluster, but I think it would make sense to make it a cluster. But if we start the dorms last call, send it to the IESG, they perhaps approve it for publication, and then it would wait in the RFC editor's queue. Perhaps go through the I guess there's the auth 48 sort of level, and then be waiting in misref for the publication of the clustered documents, because there's also, even though I'd like to have the spec pinned down, there's not much value in publishing it as an RFC until there's at least one thing that extends it. So and in fact, both of these are going to be necessary before if Ambi is the way we do the authentication, before it can go in the browser. Although there might be some value in doing CBAC for the network operators even before Ambi is done. So,
Actually,
yeah, go ahead.
Since we have Warren on, our AD, Warren, do you have any guidance, advice on clustering? Should they be sent together or not?
I would suggest getting them as much done as possible, and they can just sit and wait in the RFC editor queue in misref state until other things happen. That way, there's progress, everybody knows what's moving along, and you don't end up with sort of making mini tweaks to the document and everything waiting on everything else. Does it actually answer the question, or did I get sidetracked?
No, I think that's good feedback. Thank you. Good guidance. So yeah, I guess in that sense, and plus, if we find errata, then they don't have to, they don't have, they can still be done if it's in misref. Is that right?
Preferably not, but yep.
Great. Preferably, we don't need any errata. That doesn't always work out. So anyway, yeah, Ambi had some substantial updates. We'll be trying to fold these into the next stage of the implementation work we're trying to start doing, as well as kind of get that discussion rolling on the security considerations and getting it to a place we can seek good consensus there. Again, we haven't fully decided whether the right way to do the encryption is via Quick or via some kind of an extension to Ambi that adds encryption at that sort of layer. I'm leaning toward Quick if we can get it to work right, but I would still take Ambi as extending Ambi in some sense to provide an encryption capability, either as a separate document or as a rev on the current document. I would say are all kind of on the table for that. So that's still going to be some work in progress to make sure that we can get a sort of satisfactory encryption story going for the multicast traffic. I think there's some TBDs fixed in CBAC, but there's still some remaining work. I would put the sort of how to handle priority properly chief among them. Anybody who wants to work on that, your insight would be welcome. I think I'm just trying to make it so that you can have linked streams that say, well, if you're not going to send something else, then there's no point in sending me either, so that the network can make better decisions about doing that. Mnat has a few pending changes that have not been submitted yet. I didn't get the latest updates in, and then some bugs in the implementation that I'll be trying to sort out. But that is the doc status. So I guess the main action I'm looking for is to consider the last call of dorms at this stage. And I think that's my last slide.
Cool. So I'll make it a plan to put that out on the list. If you don't see me do that in the next few days, that means I forgot. So feel free to remind me, and we'll send out a
and then actually there is one process question. We got the early review from the Yang Doctor, but I guess there's a separate last call review from the Yang Doctor. I'm not sure if that's relevant or and which comes first, the working group last call or the Yang Doctor last call review. But I guess I should confirm with Rashad that the current edits have addressed his feedback from the early review, and maybe confirm that there's nothing else he'd like to see different. And I'm not sure if I should do that before the last call. I haven't done it yet, but
I think it would probably be a good idea. That seems like a good idea. Just he made the suggestions, and he with the review, maybe send it on and see if he thumbs up on those, and then at the same time ask does this obviate the need for a regular review, a late review, or is this good enough? And then
okay,
take it from there.
Sounds good to me. Right, so I'll do that and then ping you, and then hopefully we'll be ready to do the last call. At least the first last call. All right, I think that's it.
Great. Any questions for Jake? Nils, you're up. Nils, you're on mute, but you should be able to talk.
It says he's sending audio.
Can you hear me now?
Yes, I can hear you.
Okay, perfect. Yeah, and I don't have a question actually, you, Jake. I wanted to say kudos to all the work that you've done here. I've read not all of them, as I said, but especially the ones which I was interested. Some like the one like Mnat. I was really pleasantly surprised how well thought through that is, and yeah, if things had turned out a little bit differently, we would also be one of the ISPs to use that. So that's definitely something where I can see a good use of implementation for.
Great, thank you. I appreciate that feedback. Yeah, that's good to hear. I think there are still some improvements to make, but yeah, I think it's coming along, and I also have been pleasantly surprised with like how well Mnat has worked around some of the just problems in practice from the vendor implementations of multicast that that the ISPs have had to wrestle with. So I think there are some legs there that that might be useful. Yeah.
Well, thanks and chapeau.
Thank you very much. All right. So if that's it, then that's it.
Great. Any other questions, statements, or anything before we close down? All right. Well, I promised we would be done early, and we are. So go enjoy your Friday afternoon, at least until the next working group. And thank you for joining. And hopefully we'll someday have another. We'll meet in person in Madrid, but I don't know that that's going to happen. But if not, we'll do this online again, and look forward to seeing you all again then.
Bill, for taking the notes. Really appreciate it.
Yes, Bill. Thank you very much.
Thanks very much, and looking forward to enjoy a beer in person. Hopefully not so much in the future with you. Bye-bye.
Thanks. Bye.
Thanks. Look forward to seeing you in person.
Yeah, no kidding.
And one more plug, Stig, since you're there, PIM working group is coming up soon. I don't know if it's the next one or the one after the next, but I think it's set. It might be in 3 hours. But the day's not over. Don't forget PIM. Great. Thanks all.